My name is Beng, and I'm currently studying in Ta UMT. So currently pursuing studies in Diploma in Information Technology, Year 2, Sem 3. So now my friend will introduce himself.
All right, hello. My name is Kwek from UMT, which also study information technology, and we both are from DFT Group 4.
So we are hired as a LAN engineer by the TVC University College. So basically, we'll show the setup and designation of the local area network for the TVC University College designed by us. So now my friend will demonstrate and show about how the details.
Okay, to design this LAN in TVC UC, our customer have requested some requirement for us, which we need to design a LAN to have location A that consists of 5 departments, such as Chancellery and Management Department on the third floor, Administrative Department on the second floor, Finance Department on the first floor, and ground floor, which consists of Admission Department and Marketing Department. For the location B, it consists of 4 faculties, which is Faculty of Innovation and Technology on the third floor, Faculty of Business and Law on the second floor, Faculty of Health and Medical Science on the first floor, and finally the Faculty of Social Science and Leisure Management on the ground floor. So right now, after a few days of discussion between us, we will now share how we design this network. So in this LAN, it will total have 3 networks, which one network for location A, one network for location B, and one network for router to router. And it also this LAN is also consists of total 10 subnet, which in location A have 5 subnet, and based from our design, each subnet will have 3 end devices, 1 switch, and 1 default gateway. On location B, we have 4 subnet. Each subnet have 3 end device, 1 switch, and 1 default gateway. And lastly, the last subnet, which is the router to router, which consists of 2 router, and each router will handle 1 location default gateway, which means one router will handle all default gateway from location A, and another one will handle from location B. Next slide.
Okay, so now I'm going to share about the network design. So I will show it in packet tracer. So for clearer vision. So basically, this is the network A, the network between the router to router, and this is a network B. So as you can see, it consists of 5 departments here. So we are using 5 switches to connect to each of the departments. So we are using the copper straight through to connect to the switch to the end devices. So as you can see, this all basically like this, and we are using the optic fiber to connect from the router to the switch. So optic fiber is faster, so we are using the optic fiber. So now we are going to show the network between the router to router. So we are using the copper crossover between the router to router. So it's copper crossover is basically used between two same devices, same type of device. So the location between the location A and location B is 100 meters. So we are using this one, 2 routers connecting. So for location B, we are using the same infrastructure, but this location only have 4 faculties. So for the 4 faculties, we are connecting with 4 switches, and all the end devices we are also using the copper straight through to connect to the end devices. Okay, so it consists of 10 subnets. The first one, the second one, third one, fourth, fifth, the 6th, 7th, 8th, 9, and lastly the router to router between is a subnet. Okay. So now continue to the slide. So now I'll pass it to my friend to say about the subnet table.
All right, now I will continue with the subnet table. So this is the table that we design. As you can see, there are location A, number of hosts required, total IP needed, subnet address, prefix, subnet mask, first usable IP address, last usable IP address, and final the broadcast address. So each department have its own number of hosts required. Table. This is the table that we design. As you can see, there are location A, number of hosts required, local IP needed, subnet address, prefix, subnet mask, first usable IP address, last usable IP address, and final the broadcast address. So each department have its own number of hosts required. For example, Chancellery and Management Department consists of 20 of hosts required. But actually the local IP needed is 22. The other two are the subnet address and the broadcast address. And each subnet have usable IP address to each hosts. Next. All right. In this table, there are some differences from location A table. Based on customer request, they have considered to expand the spaces from the faculty in the future. So we have increased for the number of hosts required with 20% growth. For example, the Faculty of Innovation and Technology, the actual number of hosts required is actually 600, but consider of future expansion, we have increased the number from 600 to 720, and the rest is same as the previous table. Next slide. For the router to router is also same. The number of hosts is required to which has consists of 2 routers, and the total IP needed is 4, which consists of 1 subnet address and 1 broadcast address. And that's all from my side.
So now I'm going to share about the addressing table. So as you can see, the addressing table consists of all the devices such as routers, and devices such as PCs, and also the switches. So as you can see, this this shows the device interface, IPv4 address, subnet mask, and the default gateway of the routers, the switches in all the departments and the faculties, and also some of the end devices, PCs. Okay, that's all. So now I'm going to show about the pinging of computer to each others. So we will demonstrate it in the packet tracer. So now we are going to ping in within the same subnet mask, same subnet. So now I'm going to the command prompt. So now we ping. We are using the PCCM1. We are going to ping it to the PCCM2, which is the same which we are in the same subnet. So now we ping the IP address 172.25.0.4. So it's the receive is 4, so it's okay. So now we are going to ping the PC with the PC from the same router. So now we are using the ping the administrative PC1. So ping 172.25.16.3. So okay, you can see send 4 and receive 4.
All right, so now we are going to show how we ping from the subnet from location A to the different subnet from location B. As you can see, it is able to get the reply because we allow the network can communicate with different network because we have added IP loading to the router to let the devices from location A communicating with the location B, and that's all.
So now I do the ending part. So basically we have finished all the things. So thank you and have a nice day.
you.